it like led me to having the job that I have now. So my advice is to make connections while you can with the professors and the professionals and other industry leaders that you interact with during this whole process. But yeah, I get a lot of satisfaction out of just you know, working with affordable housing developers to make their buildings more energy efficient. A lot of my focus is around getting to electrification in an affordable way. That way we can bring, get closer to decarbonization for all of our buildings.
Thanks.
Okay, we go next. So for me, it wasn't an option. My family, actually, we have a bunch of engineers and architects. So I knew from the beginning that I had to go in that route. And I developed a love for architecture. And when I was in college, that actually in Colombia is only 5 years of architect to be an architect. So we don't have like different degrees like the US. It's a professional degree. So I knew that I want sustainable architecture and resilience from the beginning, but I didn't receive a lot of support from my professors. And that wasn't the thing in that time. I needed to focus in modernism or something else that was driven by the market. And so I decided still to go to that route, and I'm very happy about it.
Great. Thank you both. Another question, just for the teams to get to know you a bit more. When you're not working on sustainable buildings, what do you like to do with your time?
I do a lot of woodworking, my favorite pastime. I also picked up pickleball this past year, like half the world, and also pottery. So that's how I like to spend my free time.
Great.
That sounds very cool, Sarah. So I actually like anything that has to be with movement. So I ride my bicycle, I practice martial arts. I'm like a rat gym sometimes too, rock climber, anything that is outside too. And in my quiet times, I like to play piano, and maybe draw a little bit, and I think watch a lot of TV too.
Great. Yeah, thank you both again so much for joining, and thanks for sharing a bit about your path to buildings and what you like to do for fun. I think it's great to get to know people in the industry. All right, so we have less than a minute until presentations kick off, so I think we can go ahead and turn it over to the first division team, University of Cincinnati. If you would like to share your slides, we'll hand it over to you.
Thank you. We'd be happy to. We've got our whole group here in one room. So let's see, there we go. This is a rather congested one screen here.
Looks great. We can see your slides.
Awesome. Thank you. Can everyone hear us and see this okay then?
Yes.
Okay, thank you. I'm going to go ahead and let Zach lead us off.
Hello, everyone. We are the University of Cincinnati Multifamily Division, and this is How to Live. I am Zach Spalding.
Mohammed Al-Jahwari.
I'm Daniel Walker.
I'm Nate Upol. I'm Thomas Hayward.
I'm Miles Wiley.
And I'm Molly Denford.
Through How to Live, we developed three main goals. Our first being enabling mobility for travelers with a one-stop shop for travel and lodging needs. Second being utilizing renewable energy to create a greener, healthier environment for both residents and guests. And third, we want to inspire a sense of community through an integrated landscape that encourages interactions between our residents and guests.
Looks like your video and audio cut out. Can you hear us?
Oh, sure.
Oh, it looks like you're back. We can see and hear you now.
about that. It looks like our school's internet just cut out, so I'm just connecting us to a hotspot real quick.
No problem.
Okay, still sounding good?
Yes, sounds good.
All
Go
right.
ahead.
Just to repeat, our site is located in Gouda, Netherlands, just east of the historic city center of Gouda. 4 teams from the University of Cincinnati came together to showcase Gouda's ability to maintain a corridor of net zero energy buildings. Our division is multifamily commercial, and it's the third parcel of land between an office and a senior living facility. As far as climate goes, Gouda is in 4C climate with mild summers with temperatures in the 70s and winter lows in the 30s. Since Gouda is a heating dominated climate, our availability for sunlight and solar is opposite our building's energy demands. And we should also note that Gouda experiences strong winds coming from the southwest, which we address in our form design. So that's
Yeah, so as Mohammed had mentioned, with our form, we started off with a simple rectangular box, then cutting off a piece of that northwest corner to respond to the southwest winds. Then cut off a piece of our south living and kind of create this V shape to funnel that wind that we have been talking about. Fourth being dividing up residential units and our EV RV dealership. And our last step being adding elevations and dividing up programs accordingly.
For our program, we have this exploded diagram showing how everything comes together. We have our residential unit blocks highlighted in pink with the 2 or 3 bedroom units staggered along the northwest of our program, and our 1 bedroom units along the east. On the first level of each of those, there's also a small 1-bed Airbnb unit. And all of these residential blocks lead out onto the community green roof and patio, which has underneath it our energy collection storage, our RV parking storage for the electric RVs, and our utility rooms. And on the northeast corner of our program, we have our commercial block with a bicycle workshop, our electric RV garage, and our electric RV sales floor with a gym located above that for our residents. And for our floor plan, we have the first floor showing where we sit on our site with emphasis on our strong southern stair leading up to the green roof and patio, which is shown on the second floor. And then our third and fourth floors show the upper levels of our residential units.
To illustrate how people and vehicles get around on our site, this diagram has all of our pedestrian walkways highlighted in yellow. On the right-hand side, you'll see the 4 entrances to the RV Airbnb units. And then also in blue, you'll see all of our site stairways highlighted outside of each residence and the main 3 staircase entrances to the green roof. In the green spaces on site, we're going to have several renewable energy exhibits for kids that are interactive. We're going to put these together to form kind of a renewable energy playground for them to have like a unique and educational experience for them on our site.
So for our structure, our driving condition on the site was a soft peat soil found in Gouda, Netherlands. This created a difficulty creating a foundation, and so we elected to use 40-foot board piles that will reach bedrock, which then our main foundation will sit on with prefabricated pile caps, which will disperse that load. We elected to use timber and reclaimed brick for the majority of our unit structures so that we have a better environmental impact and reduce carbon emissions during construction. And then we elected to use steel for the gym, RV sales, and green roofs so that they can be repurposed in future dates to accommodate increased loads.
So this is the overall mechanical diagram for our design. The mechanical room is located under the green roof, and it has 3 types of tanks: an absorption chiller and a water softener. And we have a solar thermal array located on the roof of 1 bedroom units building. The solar thermal is the main source to generate the mechanical system to provide hot water that would be used for the radiant floor system, domestic hot water uses, and to generate warm and cold air. So this is the heating and cooling system diagram for a 2-bedroom unit. Each floor, we have 1 to 2 fan coil units, a radiant floor system. And we have 2 types of controls. One control is supply fluid temperature to determine if we need cooling or heating. And the other control is space air temperature. Supply fluid temperature, which is to maintain the fluid temperature that's coming from storage at 130 degrees using electric tankless water heater.
So as far as getting to a net zero design, we started with a baseline building that uses average values typical to Howrah. And then there are 2 main objectives you kind of have to achieve as far as getting to net zero. The first is reducing energy consumption on the building site. And so as far as that goes, we start by addressing the building envelope. And that's just a matter of reducing U values of your glazing and increasing the R values of your walls. Then we also address the equipment and lighting power densities and reduce those as much as we can. On the second side of things, there's increasing your energy production on site to make up for what you see there. That's still 155,000 kilowatt hours a year. So as far as that goes, we have 1 solar thermal array on our building and 2 photovoltaic arrays on our site. The first being on the building and the second being on a pedestrian canopy that runs north to south along that entire net zero corridor. As far as crossing the threshold into net zero, we have a small wind farm on the northeast corner of our building, which allows us to produce over 5,700 kilowatt hours each year and gets us to an annual EUI of about negative 0.7 kBTU per foot squared.
I hate to interrupt you, Cincinnati, but we are at time. So
Okay.
to keep this fair, we're gonna start the Q&A process.
That sounds good. That's our last slide. Thank you for your time.
Thank you. Sarah, Luz, any questions?
Yeah, I was I think I was about to ask questions about that square foot cost slide. I was looking at your overview page. Well, first of all, I just want to say this looks incredible. I think it's like an extremely stylish looking building. I would totally want to live here and be a part of this community. Also, I love the clever title. It's not Gouda Live, it's How to Live. I saw that your MEP also had an ERV. Is that correct? I don't know that you talked about it. Okay. I think that makes a lot of sense, especially for this climate. I am curious about the utility bill because I think in the overview side, it said it was like 60,000 per square foot, which is really high if you're considering it that as a monthly cost. And it looked like based on your envelope and your MEP design, the actual cost should be a lot lower. I don't know if that was supposed to be like an annual cost instead of a monthly cost. But even as an annual cost, it's still higher than what we would see in like a typical multifamily building. This may be because you're also considering cost for the retail portion, which I don't know what that would be, but yeah, just something to look into. Otherwise, I think this is great.
Thank you.
Thank you.
So I have a few comments. First, I love that you talk into consideration the culture of Gouda. I actually was there like a year ago, so I could see in the project all of the variants that you have cultured in the place. So that was fantastic. I think you can focus a little more on that because I think that's some like a strength of this project. So that was really good. I was reading into your project, and this is just about the language that you mentioned, that this has like all design or all features. In architecture, when we refer to all, it can mean to a lot of things: historic, old-fashioned, or early architecture. So just to make aware of the language, that if you want to consider this like an historic language in the design, So that would be better when you are doing the presentation. I was also going to ask about the payback time of the solar and wind energy. And another consideration that I noticed is the grid pattern that you have in the landscape design. It would be great to see if the person likes the pattern, because that happened with a lot of projects. They look very good from the bird view, but they are very difficult when you are walking. So the person will create those paths, and sometimes it's a little more organic, or you can mention why you did those paths. Maybe there is a store in this corner. Maybe there is something that drives the person to walk in that way.
Okay. That's a great point. Thank you.
Thank you.
Any other questions? We just have, I guess we have about 10 seconds left for Q&A, so probably not enough time for a question.
We'll give you some written feedback though. This is great.
Thank
Yeah.
you. That would be awesome.
Thank you. Thank you.
Thank you, University of Cincinnati. Great, so we have about 2 minutes before the next presentation starts. State University of New York and Syracuse. So if you want to go ahead and get your slides ready, you will be starting at 12:25 Eastern Time. How's everyone doing this morning?
We're doing good. Thank you for meeting with us.
Yeah, of course. Looking forward to your presentation. Right. I think we have just a few seconds before 12:25, so whenever you're ready, you can kick it off.
Thank you.
Hello and good afternoon. Thank you for your time. It's a pleasure to be presenting to you today. We are Syracuse Housing and Environmental Design, and today we'll be speaking with you about Windward Homes. My name is Anna, and I'm accompanied by my fellow team members, Anna Carroll, Julia, Adam, and Matt. We are students at SUNY ESF, the only college in the US dedicated to environmental science and forestry.
All right, so let's get into it. Over the years, Syracuse has become one of the most poverty-stricken areas in the United States. Syracuse was once full of vibrant communities, with the introduction of I-81, which divided the city, destroying these communities. One neighborhood destroyed is known as the 15th Ward, which is a historic Black community. With the new renovations of I-81, our goal is to revive this community to what it once was.
In designing Windward Homes, our overall goal was to reach net zero energy. We also wish to provide a safe, comfortable, and accessible environment for our residents. Our building will be able to adapt to the harsh winters and high winds of Syracuse, New York, as well as mitigate noise and air pollution. To lower our embodied carbon emissions, we will be using locally sourced and sustainable materials.
Syracuse, New York has some of the highest poverty rates in the US. Our site and the surrounding area can be seen in the middle of the map in the dark blue area. This is a low-income community zone, where 87% of households make under $35,000 a year. As you can see in the map, affordable housing is not prevalent and makes up less than 9% of the building stock. Our residents will be at or below 60% AMI, and as you can see in the graph, there will be programs to help keep rent accessible. To further fund the building, we will achieve Enterprise Green Communities certification.
Our project, Windward Homes, is a 5-story mixed-use multifamily living space with 68 1,300 square foot apartments. 36 of these units will have 1 bedroom, and the other 32 units will have 2. The ground floor will consist of a large commercial space, and our project will house a maximum of 152 individuals. These occupants will primarily consist of senior citizens and individuals who may require housing through the YWCA. The landscape of this project will serve as a pragmatic and calming environment that will enhance the building's energy efficiency while also serving as a refuge for building residents living in the inner city of Syracuse, New York. A biophilic experience will be created through the utilization of native salt-tolerant plant species like sugar maple, American beech, hickory, and shrub willow. To further improve our building's performance, these deciduous trees will be planted along the southern facade, along with shaders for the windows, to aid in summer cooling and winter warming. Coniferous trees will be planted along the western face of the building to reduce the intensity of the winds coming from the Onondaga Valley. These plantings will also reduce the noise, as Anna Carroll mentioned before, coming from the adjacent railroad and highway, while improving the air quality for residents of Windward Homes. The curvature of our design is inspired by the historic railroad that runs just north of our project site, and it does not just serve as for aesthetics. It'll also aid in the performance of our building. By having the curve projected towards the southwest, we'll be able to maximize our solar gains by maximizing the area of the building that is exposed to the intense sunlight. The curved design will also minimize any thermal bridging that could occur at sharp corners by simply illuminating them.
Moving on to our building amenities, we have the state-of-the-art fitness center, which will all be housed with zero energy equipment. All this equipment seen on screen here can reduce our energy use up to 15%. As Anna mentioned previously, Syracuse is an impoverished area and it is also a food desert. So with the implementation of our corner store, we want to supply our occupants with convenient, regionally sourced goods as like meat and produce for an affordable price. With our therapy office, mental health has been more important now than ever. We really want to give our occupants that outlet to provide them with the help they need. We offer group therapy or one-on-one sessions with the help of local support. Moving on to our health and comfort, here on our screen is a rendering of our green space. This is an area where our occupants can escape the busyness of the city and unwind with local Syracuse vegetation like Adam mentioned previously.
It is important to consider the upfront carbon from materials throughout the whole. This is why we will be using mass timber, a local low carbon alternative to traditional building materials. This switch from concrete and steel to mass timber can save tons of CO2 and thousands of dollars. A high insulation R value is needed due to the cold climate and focus on passive design. An interior continuous cork insulation, which is an effective noise barrier, and hemp wool insulation will be used. These materials focus on both energy efficiency and a local carbon footprint through low embodied energy, low carbon intensity, and low transportation costs. Additionally, we found net zero glass, which can save up to 45% of heating costs with its R12 glazing. Altogether, this creates a passive house standard building envelope, which uses 25% less energy than a typical building.
Energy efficiency is a crucial part of the creation of our building. The internal lights are all LED and the outdoor security lights are all solar powered. Water efficient appliances and fixtures combined with sensible water use will help our building save water and money. Another improvement will be adding the cutting edge Jets vacuum toilet, which uses 1/10 of the amount of water compared to a low flow toilet, and the pump can run on electricity. It is also competitive in price, so no large expenditures will be needed for this improvement. Determining the best type of HVAC system needed for a building ensures that the indoor environment will be conducive for occupants regarding the humidity, temperature, and air quality of the building. Windward Homes will have an HVAC system of 20 tons due to the building having an EUI of just 15.4. The building will use a variable refrigerant flow system, which is an electric non-traditional HVAC system. These methods will leave the building with only 600,000 kilowatt hours of energy produced each year and a source EUI of 47. The leftover energy will be generated through active systems that use renewable energy.
Windward Homes will have two distinct PV systems. Our rooftop system will consist of polycrystalline cells and a 2-axis tracking system to maximize durability and output. This system will provide half the energy consumption. To supplement the other half, we have designed a solar canopy to cover the parking lot. This choice will protect residents' vehicles from heavy snow and intense summer suns. The system will have east-west oriented panels to flatten the production curve. Thank you for your time. We believe that Windward Homes will revolutionize the sustainable building sector and reintroduce vibrancy to the Syracuse community.
Thank you. Sarah or Luz, questions?
Yeah, I just want to say the intent behind this project and the community you're trying to serve is really admirable and addresses some critical issues that we're seeing around housing and affordability and social equity. So kudos for that, especially a place like New York where affordable housing is a serious issue. I also really like the corner store idea, addressing diet and accessibility to good food as a way of addressing healthy living. In general, I would say this is like a very realistic looking project. It's something that I can see actually being designed and built here. Really like the intentional use of vegetation and landscaping to, add green space. One note is as far as the envelope values go, the the windows and the foundation insulation seem very high, like to a point where I think we might be seeing diminishing returns on performance, but like the cost would get like astronomically high with some of those. The other question I had, I think the MEP system with the VRF is great. I was wondering if you had any thoughts on how you're going to address water heating, because that's usually another pretty big source of energy consumption.
Yeah, so that's a great question. For water heating, we'll be looking at a domestic hot water heater that uses electricity. That is something that we'll be looking at if we make it further in the competition. That was one of the notes we had to look further into it. We had a few of those just like, oh, this is something that we need to consider. So yeah, that is one of those that we'll be looking into further.
Cool.
Great. Yeah, I really like the point of view about the cultural and local aspect. I just have a question. What is the demographic of the place?
So the inner city of Syracuse, where we're designing this building, is primarily low income and typically like Black and African American residents who live in that area. And that's the main demographic we're trying to serve, as this neighborhood that was historically a Black low-income neighborhood was destroyed by the introduction of I-81 in the 1950s. Those people never left the city. They kind of moved to just the surrounding areas, and the goal of our project was to give them their homes back.
Okay, thank you. So one comment that I will do about that is that the design have to show how me as a person of color can belong to the place. And culturally, there are aesthetics, colors, ratio of light that will be impactful when you put those in the place. And that I think that project will benefit from something like that. And the last question that I have is, what is the ratio between the wall and the glass?
Yeah, so that is a 30% ratio. And like I had mentioned, the glass windows would be R12. There was around a 2 to 7 year payback for those. It's like a new technology that is coming out soon. So
thank you.
Any more questions, Sarah or Luz? All
We're all
right.
set.
Well, thank you all for your presentation. And next group will be the Indiana University and Purdue University, Indianapolis. And we will get started at at 12:40 Eastern time.
Thank you for your time.
Thank you.
Thank you.
We got about a minute before the next presentation starts. Indiana, feel free to start sharing your screen whenever you're ready. And looks like we're at time, so you can begin.
All right. Hello, everyone. My name is Evan Carlson. I'm the student team lead for Enviro Indy. We represent Indiana University, Purdue University, Indianapolis, IUPUI. Specifically, we're all from the School of Engineering and Technology. Today we're showing off our multifamily building project, our multifamily building project 016. How do I do next slide? Oh no, there we go. Joining me today for this talk is Megan Hall, also the student team lead, Whit Grote, Kristen De La Rosa, and Safisa Moyo from the electrical engineering team might join in on the Q&A. Our core team is made up of entirely undergraduate students from multiple different programs within the school, such as interior design, architecture, and electrical engineering. Here on the slide as well, we've put in a lot of the faculty who has just helped us to make Enviro Indy happen. Of course, being undergrad, we kind of have a lot of people we had to talk to in just getting this whole project off the ground. We couldn't have done it without Daryl Nicholson, our faculty lead. And without further ado, now on to Megan for the contributors.
Our team would also like to thank Current Architecture, Cloverleaf, our solar decathlon mentor, Kevin Vandeman, and all other campus entities that have assisted us in our research this far. We will now be getting into our design goals and the evolution of our research. Our building shell starts with a single shipping container. Our interior design program has been conducting research on the repurposing of these containers and the positive impact they can have on our environment. These containers also already come with the structural integrity that we need in order to construct our building shell. Our design is a new construction building that is made up of 5 floors with 12 total dwelling units and minimal modifications to the shipping containers. These units vary in size from 706 square feet all the way to 1,800 square feet. 40% of our building is dedicated to commercial spaces located on the bottom 2 floors. We also incorporated a shed roof, which is easy for solar panel installation that will help us reach our zero net energy building goal. Moving on to the target market for our building, we have directed this building towards the IU students themselves, as the site location is very close to the IU Medical School and also the law school. Now I'm going to hand it back off to Evan for our climate considerations.
Yeah, so for our local climate consideration, our goal for our multifamily building is to hit that 81 kilo-BTU per square foot per year. And to do that, we have to keep in mind Indiana's climate. We're in the kind of cold region of this from this map. What this map tells us is that we're going to be spending a lot of our time heating more than we're cooling, and we just want to keep that in mind with our HVAC system. And this is our site here. It is about 15 minutes away from campus, and it has plenty of room for solar panels. An important part of our site is that it's in a place called 16 Tech. It is Indiana's innovation district, and this is right near where our campus lives, where our target market lives, and it's right in the heart of downtown Indy. And now on to Megan for some of the interior architecture.
Our senior interior design students design customized layouts for all spaces of the building, and this is an example of one of those designs. They utilized evidence-based design practices when working on this project. They included both floor plans and reflected ceiling plans, and also specifications for their fixtures and equipment. Those specifications are then put into our tool designed by the electrical students to confirm that we're meeting our energy goals that are set. Our interior students also made sure to utilize the International Building Code, International Residential Code, ADA compliancy, and NFPA. I will now hand it back off to Evan to talk about how we intend to reach net zero.
So reaching net zero is, of course, the kind of big point of this project here. And so for net zero, to reach that, we had the electrical engineers, Whit, Safiso, and Christian. They've built this little tool that allows the interior design students, as they design different room ideas, different layouts, and different lighting and plug loads, we can actually put all of that directly into the calculation tool. And what it'll do is output the power consumption versus generation, and that will hopefully allow us to hit net zero. An example here is this gym room. This render was designed by one of our interior students, and all of the equipment that you see in this image, all the equipment that they've planned out, we can throw that into the tool itself and get a really nice number out of it. Our solar generation model, we have about 272 panels. Our estimated array output is 474 megawatts, and these are where we want to place our panels on our roof just for the maximum efficiency. We chose these SunPower X Series commercial solar panels because they just have a longer lifetime compared to other panels that we looked at. The battery specs, we chose these batteries because they are very efficient, and as well as that all of the battery system is self-contained. These boxes, they come in, they have all of the communication like IoT, inverters. These batteries have a high capacity, and we just thought that was a very interesting option. And to store all of our energy in those batteries, we wanted to have a room specifically to put them in. And the idea is actually using a tempered glass storefront so that people walking by, the general public, can actually see inside our battery room, and they can see that they're turning on, charging, discharging. And it really gives the feeling that our building is in motion. And this room is on the exterior south end of the building, so in case we might ever have to increase the size of the room or annex or change things, it's in a place where we can do that. Our HVAC system, our idea is to use variable refrigerant flow in a geothermal system. The idea for geothermal is that the ground, underneath the ground, it's really warm and we can get our energy for free. We don't have to get it from elsewhere. And that's a very tempting option. And right now I want to point out that our HVAC system is still, we're working on it. And as well as working on the HVAC system, our plan for the final submission is to continue our interior architecture, building design, and lighting, as well as advance the exterior building shell design. We might have to change things and advance the MEP study of the project to make sure that we hit net zero. That's our entire goal. And so I hope you enjoyed our presentation. This is the very first time IUPUI has done the solar decathlon at all. Is there any questions?
Yeah, thank you. I love the shipping container idea. It's very industrial and low embodied carbon. You're upcycling building materials. As a design competition with like a focus on net zero design, I'm curious to hear a little bit more about the MEP and the envelope performance, which are kind of the key indicators of an energy efficient design. I know that you're still working on the HVAC part, but I would say that MEP and envelope needs to be a very early part of the design conversation.
Okay.
So have you thought about like what wall R value or the roof R value and how that's going to impact your energy performance?
We have not gone very deep into calculations, no.
Gotcha.
I really like the project. Sorry.
Go ahead.
Okay, thanks. I think the repurpose of a material is very clever. And I just have a question. Like, you decided to use a battery to storage the surplus of energy that you're going to have. And I just something to think if it is cheaper just to give away that energy to the community, or even think, because I see that you have a big lot, maybe think to have a community solar panel garden where other people can benefit for that. So yeah, I think that's one of the points, and I was just thinking the same with Sarah, that about the fenestration is very important. And I would love to see, because I see the potential in this project, some passive strategies. And the location, I think, is very appropriate for that kind of strategies that will lower the cost of the project.
Okay, I will keep that in mind. So make sure we get all our R values and think about other ways to get solar energy and other passive.
Also, have you considered the potential impact on the structural integrity of the shipping containers as you remove large sections of it for glazing? I think that as you're thinking about fenestration, that's also something that needs to be considered.
I'm not sure we have.
I do think we have looked into that with the initial design of the building envelope. And I think we could include more information within our presentation about how that is affected and how we combat that.
Gotcha.
If there are no more questions, thank you to Indiana University and Purdue University Indianapolis for your presentation. And yeah, we will take the next few minutes as a recess before the next presentation at 1:25 Eastern. Sorry, 1:10 Eastern.
Thank you.
Thank you.
Thank you. Yeah, sorry, 12:55. I have a lot of times listed in front of me and my eyes are going crossways. Thanks. We have a little less than a minute before the next presentation. So Concordia, if you would like to share your screen, you're welcome to do so. All right. You can see your screen. The floor is yours.
All right, so good afternoon, everyone. We're Les Avenirs from Concordia University in Montreal, Canada, and today we'll be presenting La Pépinière. I'm Alessandra. I take care of the structural part of this project.
My name is Anis, part of the envelope and HVAC team.
My name is Valerie. I'm part of the mechanical team.
My name is John, part of the envelope and the cost estimation team. Name will be part of the HVAC team.
So the location of our project is in Ville-Saint-Laurent in Montreal, Quebec, which is in a low-income neighborhood and multicultural neighborhood, which ties into the main design objective of our project, which is affordability, all while remaining energy efficient. So this is the project that we're designing. It's a multi-unit housing with 32 units on 4 floors over and above an underground parking basement. So the primary material used for our building is steel, and the foundation will be built in concrete, but the whole building itself is in actual steel. So based on the National Building Code of Canada, these are an example of the gravity loads that are being applied to our building. This is an example of the lateral loads applied in the east-west direction on our building. And this is a preliminary model of our building on the structural program ETABS.
Moving on to the envelope systems of the building. For the above grade wall assembly, it consists of a steel frame using flax insulation as well as aerogel blanket insulation and with a brick veneer facade. For the flat roof assembly, this one consists of a composite steel deck provided by Can-Am with a double insulation system of flax and cork, as well as a silicone cap membrane. It's worth noting that the RSI value of the flat roof is 9.17, which translates to an R value of 52. While for the wall, above grade wall, it's an RSI value of 6.57, which translates to an R of about 37. A condensation analysis was performed, and as can be seen, there are no condensation that occurs anywhere in the wall or the roof layers. The below grade wall focuses mainly on maintaining a cheap assembly profile and on moisture control. Whereas the internal partitions planned for this building are acoustically insulated and fire resistant. The glazing system we selected was provided by Sublime Windows, which is a triple pane glass low E coating with argon gas filling the cavities. It also includes a joint seal of polyurethane extrusion to account for any movement of the exterior brick veneer. As we can see, the SHG coefficient is about 0.24 with a window to wall ratio of around 2 to 3%, and total RSI value of 0.86, which translates to R5, give or take. As a summary, our values are obtained, our values are highlighted in green, and they're compared to the National Energy Building Code of Canada requirements, but they're also compared to a 25% adjustment to those requirements. And as you can see, our values exceed both of these.
A proposed solution for the energy saving is the replacement of the southwest staircase curtain wall by a BIPV facade. The facade, composed of a total of 28 bifacial modules, would cover the entire 31-meter square area. The reasoning behind the initiative is the efficient use of valuable glazing area, which would otherwise have little benefits, along with being a source of heat loss. The energy generated by the BIPV project is determined based on location, orientation, and equipment specification. The results show that a proposed system can be expected to generate close to 106 kilowatt hours annually, which can cover at least 40% of the lighting consumption. In order to offset 100% of the lighting load, a secondary PV system may be installed on the roof, covering about 35 meters square. A preliminary energy analysis has been conducted to assess the building's needs and performance. The building is designed with an occupancy of 1 person per 200 square foot for the apartment units. As of now, the building needs are provided by 3 different systems, one for each main facade, south and north, and a third one for the underground garage, which only includes lighting, equipment, and ventilation by direct exhaust. Further analysis is required to confirm the results. However, the main takeaway is that the high-performance envelope and efficient mechanical design seem to allow for significant reduction in heating consumption. Additionally, the building's electricity consumption is around half of the minimum required baseline, according to Canadian standards.
The HVAC system is using LG water heat pump as a primary source of heating and the gas boiler as a backup system. An envelope PV will be installed into the HGU unit to save up to 70% of energy. And the cooling mode is similar to the loop of the heating mode, but going to the opposite direction. Since not all the HGU has come with the energy wheel, so instead, so we choose a semi-customized HGU instead of fully customized because it's more flexible. It's more flexible than a regular HGU and more durable than a fully customized. And so far, the chiller we chose is the Aquas. So far, the chiller we use is Aquasnap air-cooled chiller with a 30-ton capacity, which has a EER of 10.4. And the fascinating part about this chiller is that we can install this underground, like in the mechanical room in the basement, without a cooling tower because it's air-cooled. And the boiler we use is TFT 340 high efficiency condensing gas boiler, which is an energy gas boiler, energy style gas boiler. We use emit 50% less CO2 to the atmosphere, and it can save up to 40% of heating bill.
Moving on to the duct layout. It starts at the basement where 2 AHU lies in the mechanical room. We can see the distribution up to the vertical shafts. Here is the distribution for a typical floor. The supply is in blue, the return in red, and the exhaust in orange. Here is the distribution for a typical unit. For plumbing, we have solar collectors that are used to heat the domestic hot water. A condensing gas boiler is used as a backup heating source. To bring the community together, we plan to add a communal garden. The rainwater will be collected on the roof and used for this purpose. Coming back to the basement, we can see the municipal water inlet at the top left corner and the distribution to the mechanical room and vertical main pipes. Here is the horizontal pipe layout for a typical floor. And here is the water supply distribution for a typical unit.
A quick word on the cost estimation. As we know, based on our neighborhood profiles, our goal was to reduce the construction cost as much as possible, which would then entail a reduction in the unit pricing and would make the units much more affordable. As such, a preliminary estimation gave us a total value of around between 9 and 11 million Canadian dollars. But then we started performing a more detailed analysis using RS Means 2011 data. And after being adjusted for CPI and inflation, just for the envelope and some of this structural components, it would come to just under $2 million. So we are confident that we can land well under budget. We've been the Jardinier team. Thank you so much for your attention.
Thank you. I have a few quick questions for you guys. With the MEP design, I'm just out of curiosity, did you guys consider an all electric design for the project? I'm just curious if this was like an early design goal, and having gas backup was a decision based on cost, which would make sense.
So the main reason, we thought about the all-electric MEP. It's just that we had a design concern about the temperature. So our temperatures go, we have a design temperature of -27 degrees at the least, and we want to make sure of the occupant safety. So we have to have a backup system in case we have an electric, power outage, and because we also know that the heat pumps and chiller will not be operational at very low temperatures, we have to have a reliable backup. That is why we chose gas as the backup gas boiler.
And also for plumbing, it was more efficient to have condensing gas boilers because it heats up water quicker, so you lose less water that way.
Yeah.
Very nice design and presentation too. I think the data was very clear. I like that about the presentation. I think maybe you can explore a little more ideas about wellness into the building. It has that potential. I have a question about the seismic activity that happen in the region. So the selection of materials can be a little heavy for seismic activity. Have you explored any ideas in vernacular materials that can be have a better performance in these movements?
Yeah, so the two materials that were considered for our project were steel and concrete. And then because of the recent earthquake that happened earlier in September, October, we decided to design our building in steel because because of its ductility and it's better performing in seismic activity compared to concrete. Now, we know that steel is heavier, but with our design, we designed for the minimum sections. So the sections of the steel beams and columns, they're the minimal sections. So they aren't as heavy as if they would be designed in concrete.
Another question for you guys. Do you have a sense of what the average utility cost is in this area for similar sized buildings?
So usually for an average household, it's about 40 kilowatt per hour per day for one single household. In this case, we have calculated, we have 4 floors, 32 units, then we have a central heating cooling. So we're providing central heating cooling to all the occupants. So in average, throughout the entire year, is about 1,200 kilowatt hour per day. So with the low cost of electricity from Montreal, because it's from Hydro-Quebec, so we have the lowest electric cost throughout the country compared to United States or others and other province. So it's about 6 cents per kilowatt hour. So in total, throughout the year, the utility bill for the entire building is about $28,000. So if we divide that by 12 months by 32 units, so each unit will be paying about $73 per month.
Oh, gotcha. Okay.
Which is like half the average cost of the utility bill. For example, me, I live in Hanoi, I have to pay about $180 per month for the electric bill. On this case, it's 73, which is actually less than half.
Okay, thank you. That was helpful.
And the last question that I have, what is the cost per square feet of the construction?
So far, we haven't nailed that down because we don't have a complete detailed estimate for all the systems. Like I said in my presentation, we only estimated the entire envelope system, which includes below grade, above grade, the roof, all the floor slabs and the interior partitions, as well as some of the structural elements. And that came around $2 million. But from cursory literature review we performed earlier in September, October, we found cost per square footage to build such a residential structure to be around between $290 and $295 Canadian dollars per square foot. But we're fairly confident that we'll hit somewhere below that target.
Great. Thank you for your wonderful presentation.
Thank you.
Yeah, we are at the end of Q&A time.
Thank you.
Thank you, guys. That was great.
All right, so we have about 2 minutes for our next presentation with New York City College of Technology. So Brittany and I have 2 different versions of the schedule, and hers says there's a break right now, and mine says that we have New York City College of Technology. I think if New York City College of Technology is on the line, your presentation time is now, but if not, I think we might be at our break time. Not hearing anything or seeing any screen sharing. So we have a half-an-hour break. 1 moment. All right, so we will resume at 2:05 Eastern time. So we will see you back in a bit. Thank you. Hi, everyone. Hope you all had a nice break. Wanted to let you know we have about 4 minutes until the next presentations begin. We will have University of Missouri presenting. So, see you in a few minutes. We have about 1 minute before the presentation time slot begins. University of Missouri, if you are online, you're welcome to start sharing your screen. All right, give it another 20 seconds. So we're right at the 2:05 mark, and then you can take it away. All right, we're at 2:05, so you're welcome to begin your presentation whenever you're ready.
All right, thank you. Hello, everybody. My name is Aiden Kurtz.
I'm Jackson Reeves. And I'm Han Ben Kim.
We are also grateful to receive help from our faculty lead, Lyria Bartlett, the Architectural Studies 4323 Sustainable Technologies class, and our design, engineering, and contracting partners. We are excited to present Solar Grid, our mixed-use, low-income, multifamily development in downtown Columbia. In 2013, the Columbia Housing Authority reported that the city needed an additional 8,000 housing units. Our research indicates that most of the existing public housing in Columbia is dedicated to seniors and larger households, despite a majority of Section 8 housing voucher applicants being young individuals. Douglas Park, a historic region just north of downtown, has the highest density of those in need of low-income housing. Our goal is to provide an enjoyable option for impoverished, single, non-seniors, and small households in the nearby Douglas Park neighborhood. Current options provided by the Columbia Housing Authority are outdated, distant from existing communities, and have high utility costs. Our site is located at 701 East Ash Street in Columbia, Missouri, on a plot shared by the Armory Recreation Center. We exist in the 4A mixed human climate zone. We chose the site for its adjacency to Douglas Park in downtown Columbia and for the community benefits that the Armory provides. We're integrating community services through improved walkability, flooding mitigation, and the inclusion of the Columbia Armory Recreation Center into our design budget. We will help enhance the functions of the Armory and support it in times of emergency through rainwater retention and stored solar energy. We will minimize embodied carbon through the use of regional low-carbon materials and prefabrication. Occupant experience will be improved through the use of biophilic design and optimized thermal and air quality. Smart technologies and renewable energy will help affordability for our tenants. We are a 6-story, 55 residential unit complex with 13,000 square feet of commercial space. 1 and 2 bedroom modules stack atop 2 stories of commercial and amenity space to form a staggered grid-like facade with opportunities for privacy and passive shading. The building volume responds to its setting, echoing the scale of the courthouse to the south and of the low-rise residences to the north. The stepping down of the roof creates opportunities for resident community spaces. The modularity of the design allows for ease of construction and replication. So you can see here how the building responds to the nearby courthouse and residences. The U-shaped exposed exterior circulation surrounds a semi-private courtyard and container garden resting above the subterranean parking garage. Replanted coniferous trees placed along the northwest edge of the courtyard will help mitigate wind infiltration, while low-impact landscaping will help prevent flooding for the community to the north. A cantilevered solar array will power the building with renewable energy while providing shading during the hot summers. Co-op and commercial space between the armory and solar grid will help produce income for the building while mimicking the developed alleyways of the North Village Arts District. A bridge connects the on-site armory, eliminating the need for certain amenity space within solar grid. A city recycling center also exists in the northwest corner of the site. So we've zoomed in on a 4-unit cutout to demonstrate a south and north facing condition. Solar panels help generate on-site energy and provide passive solar shading in the summer. Research has shown that integrating plants and natural materials improves occupants' mental and physical health. Staggered exterior circulation provides opportunity for porch space and vertical communication amongst residents.
Solar grid is constructed around a post beam panel mass timber frame. Glulam columns and beams support fire-rated cross-laminated timber panels. Component prefabrication allows for quicker construction and easy customization. Plumbing walls connect the kitchen and bathroom between units, while high-efficiency hybrid water heaters can service 2 units at a time. Heating and cooling loads will be met by a new hybrid VRF system and DOAS ventilation with an ERV. Our climate allows for efficient performance from air-to-air heat pumps at a low upfront cost, as well as reduced operational costs, while providing occupants excellent thermal comfort and humidity control. Exposed wooden interiors from the mass timber structure and natural daylighting improve the mental and physical well-being of occupants. Smart technologies like optimized thermostats, high-efficiency ceiling fans, and plug-load switches improve the air and thermal comfort. Efficient appliances and fixtures reduce overall electricity consumption. The on-site Armory Recreation Center is also a community storm and disaster shelter. Our building's proposed water recycling and solar energy stores will help supply this facility in times of emergency. We are currently experimenting with a product that would enable our drinking water to be collected off the grid as well. Our building envelope is assembled with a staggered stud cavity to prevent thermal bridging and increase the amount of dense packed cellulose fill. A layer of graphite polystyrene sheathing and metal cladding provide resilience against moisture and storm damage. Our lobby uses a green wall and thermal mass terrazzo flooring to reduce heating and cooling loads of a large space while letting in plenty of natural daylighting. The roof and courtyard are large surfaces that can collect and recycle rainwater into gray water systems. Local native, low-maintenance prairie grasses planted outside of units reduce cooling loads and improve occupant well-being. Building design maximizes passive strategies with strategic selection and placement of windows, providing natural cross-ventilation through the units. A large part of our design was choosing low-embodied impact materials as we're running out of time to meet the Paris 2020 climate goals. Our use of mass timber in place of traditional steel and concrete structure reduces our carbon footprint by up to 22% without factoring in sequestration. We also found low carbon alternatives for concrete when it is needed and rigid insulation sheathing as well. Regional material selection and prefabrication reduces transportation and assembly costs. Currently, our building has an EUI of 27.83 before PV. With the addition of a solar array, our current models have us around a score of 16, but we will continue to optimize our design to reach the 2030 target. Our current HERS score before PV is 43, but we will also continue to reduce that score with a solar array.
So going forward, we will continue to optimize our building performance through iterative energy modeling, consultation with industry professionals, and cost-benefit analyses. Thank you for allowing us to share our design solar grid with you, a building dedicated to affordability, occupant comfort, minimized embodied carbon, and integrated community services. Thank you.
Thank you. Sarah or Luz, questions?
Yeah, thank you for that. I can tell a lot of consideration went into like the envelope and making sure that it's low embodied energy. The prefab component, I think, helps quite a bit. I had a question. You showed this on a slide, and I just wanted to ask more about it. This is a solar array installed above all of the central equipment, like the DOAS and the ERV. Is it
Yes.
raised above? Okay.
Yeah, we're still experimenting with the optimal height and whether or not we can have vertical versus horizontal discharge of air, but we should be able to raise it like an efficient height.
Gotcha. Are there any wind concerns with the solar array being raised so high above the roof?
We're still looking into it, as well as just general wind concerns, but we think that we have precedent for it not to be a concern just through other cantilevered solar arrays.
Gotcha. Thanks.
Thank you for the considerations in passive strategies. I have a question about the design strategies for seniors. I saw that you are going to use smart technologies. How you plan to make these smart technologies affordable, since cost looks like is one of your biggest concerns?
Yeah, we think we'll have plenty of opportunities just for funding from the city of Columbia already, where we our budget will already have a lot of takeoff from the city. And so I think by lowering some of the higher costs in our budget from the city, we'll be able to afford some of these more like luxury items that'll actually help affordability, and we can market it as an incentive because it'll lower overall cost for our building. But that's still something we're looking into as well.
I have another question. I noticed in one of your slides you were showing a pretty significant amount of unconditioned spaces. I'm curious, are you saying are these occupied spaces that are going to be like passively designed to be thermally comfortable year round, or are they just like corridors and spaces that people are just passing through?
Yeah, the unconditioned space that we marked, it's all just corridor space to get from the exterior to your unit. We just wanted to mark it because it is a significant portion of our design, but it's not anywhere that anybody will be staying for too long of a time.
Gotcha.
So following that question, what are your solutions to integrate the outside and inside for wellness benefits?
Integrating the outside and the inside. The outside benefits for wellness are just integrating that community garden, giving people the opportunity to grow their own food and just a connection to nature. We know that there's tons of research to prove that just improves the mental well-being is like greenery in a courtyard, just access to green space in general, and then connecting that to the interior through introducing co-op spaces where people can actually begin to sell that food or sell just their services, so that there's a chance for upward mobility for some of these tenants. We think that would improve their overall wellness and their chance at upward mobility in life.
We have a couple minutes left for questions. Any more from Liz or Sarah?
I was just looking at your utility costs. You mentioned this area has generally high utility costs. This is more just feedback than a question, but it looks like the 4820 a month for a building of this size, it's like pretty on par with what we would see for operational costs of like a gas building, which is typically a lot lower than all electric. So it's kind of cool to see, all electric design kind of showing the same utility costs as a gas building would.
Yeah, we think we can get that number quite lower too. Those were off of some of our original energy models, and so as we continue to update, we think we can get it even lower.
Cool.
Great. Well, if there are no further questions, thank you, Missouri, so much for your presentation, and we will prepare for the next presentation. Thanks.
Thank you all.
Thank you.
All right, so next up at 2:20 p.m. Eastern Time, we have Virginia Polytechnic Institute. So very cool camera you all have. Nice. All right, so you have about 3 minutes or so until presentation starts. All right, you have a little less than a minute before the time slot. You're welcome to share your screens with Virginia Tech. And just a few seconds from the time slot. Trying to stick to the schedule. All right, whenever you're ready, you're welcome to begin.
Hello, my name is Sarah.
I'm Monsi. And I'm Garrett.
We are part of Team New Roots from Virginia Tech's Washington Alexandria Architecture Center. And this is Plant, Potomac Living at Newtown, a multifamily project with community scale renewable energy production. These objectives have been the focus of the design since the project's conception. The overall goal is to have a holistic living experience with seamlessly integrated green infrastructure. The site is a brownfield due to the decommissioned coal plant, but it is more responsible to revitalize an unhealthy site rather than take up an unused space somewhere else. We have a comprehensive public transit system here in Alexandria that connects us to the greater DC area. Many residents rely on this system instead of driving. Additionally, the main climate concerns are the drastic changes in humidity between the summer and winter. The Alexandria area, especially Old Town, is in serious need of housing options in the low to moderate rent range to help create a healthier neighborhood that can be enjoyed by a diverse group of people. Plant will include units that are accessible to a wide range of income levels. The city has proposed a plan to demolish the coal plant and develop the site into a mixed-use residential neighborhood. Plant will be a single block within the 5-block development, and powering the plant and the rest of the neighborhood will be a new green energy power plant that reuses the smokestacks as a nod to the history of this site. Excess energy can be carried to the rest of the city by the transmission field located directly to the west. We are using materials that have a lower carbon footprint and are sourced from regionally local manufacturers. CLT, for example, will make up the structure of the building since it has less embodied carbon than concrete or steel. And let's be honest, it looks really cool. The facade features an exterior wood shading and rain screen. Folding window screens provide additional shading. And further, the retail space on the ground floor is separated into clusters with shaded gathering spaces in between.
Plant speaks to the historic townhomes of Alexandria and preserves the human scale of the massing to its stepped and terraced corner. The south side of the building is tapered to let in natural lighting into the courtyard and the facing units. The opaque wall surface allows Plant to reach energy targets to provide comfortable living for the residents. Plant hosts 4 cores of living with its own amenity spaces. Each one of the cores has a cluster of 5 to 6 units, sharing a common area that contains community kitchens, decks, and living rooms. Each cluster also has access to a beautiful roof terrace and its own lobby and cafe for leisure, as well as retail spaces. The format of the plants encourages residents to a sustainable co-living through affordability, convenience, and community building. These clusters are designed to fit within a 20-foot by 20-foot structure grid. The organization of the rooms, units, and clusters allows for plenty of light into each room, as well as views to the courtyards, green spaces, or to the Potomac River. Plant provides access to natural lighting and spaces with circadian rhythm to improve sleep, mood, and more. As we develop Plant further, we are referencing the WELL standard to create a holistic and supportive occupant experience by implementing physical activity and restorative spaces throughout. Located in a Climate 4A zone, Plans aims to provide a sufficient and comfortable occupant experience. Alexandria's passive house standard for the envelope calls for a minimum of a R31 wall rating and a minimum roof rating of R61, which we will be meeting through the use of 6 panels and other components. With a projected wall rating to be R38 and a roof rating of R68. Based on the envelope, the EUI is 13 for heating and cooling. In addition, we have also considered electrical and miscellaneous loads, which is projected to increase the EUI to 26.
As mentioned earlier, we are envisioning a new power plant to offset our EUI. We will replace the existing decommissioned coal power plant by engineering a clean and renewable energy source to clean the polluted landscape and support our wider site while producing renewable electricity. The proposal includes reusing the plant's smokestacks as solar updraft towers and adding a photovoltaic farm within the updraft system's greenhouse-like collectors. The photovoltaic system will function as a microgrid supporting our proposed housing development and the other buildings being planned by the city. We will also utilize the Potomac River's estuary properties to generate electricity in a new tidal lagoon. In addition to power production, the power plant site will house hydrothermal carbonization systems for waste management, batteries for energy storage, and other more minor mechanical systems. We project that the plant could produce over 3,300 kBtu per square feet per year across all of the generation methods. We expect the photovoltaic grid to produce 210 kilowatts per hour and the updraft towers produce around 50 kilowatts per hour. We need to revisit the tidal energy numbers as we are expecting less than is shown on the graphic. The solar plant can produce the majority of our site's demand. The other systems can function while the solar panels are inactive overnight. Altogether, the power plant can produce 1,100% of our building's energy demands, or over 200% once the site is fully developed. This gives our site the ability to function as a microgrid, powering itself independently in the case of a wider grid outage. To integrate the power plant and multifamily, we are centralizing some of the mechanical systems into the power plant. We will utilize the nearby Potomac River for cooling and in other non-potable water systems. The power plant will also collect the site's waste for hydrothermal carbonization to produce electricity and other reusable byproducts. These systems will exhaust heat that we can then utilize in our solar updraft towers. Centralizing these functions allows them to be more efficient, as well as streamline our multifamily building and the future developments.
This site was once used to store millions of BTUs of coal, which had massively detrimental effects on the environment and the health of the Potomac River. Now, the site produces significantly more power than it did before and is a valuable community resource. We are Team New Roots because we're planting the idea of sustainable living into Alexandria to start a movement for the future. Thank you for listening. We're Virginia Tech's Washington Alexandria Architecture Center.
Thank you. All right, you now have about 5 minutes for Q&A.
Thank you. That was very interesting. This is a very cool use of the space, reusing the power plant. Can you tell me more about how the solar updraft towers are used to produce power? Are there turbines in there?
Yeah, so sure. The greenhouse extensions that we have shown on them are meant to superheat the air, which will pass through the smokestacks, turning a turbine, like you said.
Gotcha. That's very interesting. Is there precedent for this, or is this an original design?
Solar updraft towers in general are relatively new, but they have been built in countries like China, and particularly Africa is exploring them just because they're extremely low maintenance and few moving parts, and they're pretty cheap.
Gotcha. Very cool. And it also kind of addresses concerns about like heated air beneath solar panels since you're drafting them out. Are there any concerns about contaminated soil on site, and is there any issues with site remediation and having a residential building built on top of this site?
Of course, it's always a concern. The health of the individuals who are living there are of the utmost importance. In the excavation process, a lot of the contaminated soil can get removed. Though that is an issue that we are continuing to be aware of and study more as this project progresses.
So you mentioned about the adaptive reuse of this plant. What is the cost of this, the payback time that you have proposed for this project?
Once we have rerun the numbers, as we said, we're reevaluating them at the moment. But once we get that, we're going to try and look into the actual payback period. Like we said, right now it can power potentially the entire development, including the blocks that we aren't even designing at the moment. So
in short, we expect it could pay for itself once it's up and running. It'll be significantly more efficient than the initial coal plant ever was.
Since the area of District of Columbia is so expensive, how do you plan to make this project affordable?
Well, we know that the city is really interested in the site. We have been working with them. We expect there will be some city funding subsidies as this goes along.
There will also be the availability to have some affordable housing units, something under 80% AMI, 30% AMI, which we can utilize with Virginia tax credits to help afford for affordable units within the space.
So I have time for one last comment. So I know in your overview page, you mentioned the project is not in at risk of flooding. I still think being this close to the river and with more issues we're seeing with climate change, it would be worth considering adding some kind of flood resiliency to the design here.
yeah, I think one of our ways we were looking into doing that was restoring some of the natural wetlands along the Potomac shore that has been, degraded, especially by the former coal power plant, so to prevent soil erosion and whatnot.
Yeah, that's a great idea.
If there's no further questions, thank you, Virginia Tech, for your presentation.
Thank you.
Thank you.
All right, and our next and final presentation of the day is the University of New Mexico. That presentation will kick off at 2:35 Eastern time. So about 3 minutes. Right, University of New Mexico, if you're on the line, you're welcome to share your screen. It's a little less than a minute for your time slot. We're not seeing or hearing anything from University of New Mexico, but we'll give them a couple minutes in case they are running late. We're still not hearing from New Mexico, so I think we will end the day here. Thank you to all the division teams for your wonderful presentations. We really enjoyed seeing them and learning about all the work that you put into these projects. So we will reconvene tomorrow at 10 a.m. Eastern time for the second round of multifamily building presentations. So thank you all again and enjoy the rest of your day.
Thank you.
Thanks, everyone.
Bye.